All right, in the second tutorial, we're actually just going to be reviewing how to find trig values of all of your angles. They're going to be a little bit more complicated problems than the previous ones we've looked at, but let's go ahead and do that. So here's one of our problems. Beta lies in quadrant 1. It's nice that they give me what quadrant we're in. And the cosine of beta is equal to 3/7. I want to know what the sine of beta is and what the tangent of beta is. All right, so the first thing I'm looking for is, can I use my unit circle? Because we spent all that time looking at all those and memorizing those angles and those distances, and unfortunately the answer is no. 3/7 is not one of our special cosine values. So that means that this is a triangle problem. That's how I solve it. I think it's pretty easy and visual to solve it that way. I know that there's basically an angle, and I know that it's in quadrant 1, so I'm just going to draw any angle in quadrant 1. We always originate from the origin and draw out into our quadrant, and then connect a right triangle down to the x-axis. So that's where beta is. I'm just drawing a visual. That's what beta looks like. It's someplace in quadrant 1. Now I know that the cosine of beta is 3/7, and that's when I go back to my sine, cosine, and tangent, my SOHCAHTOA. I'm given the ka. So that means I'm given the adjacent and I'm given the hypotenuse. So I can make the 3 the adjacent leg and 7 the hypotenuse. Adjacent to where I am would be here, 3. And the hypotenuse, of course, being 7. So all I'm missing is this side right here. I'll label it as a y for right now since it's the y direction. It doesn't ring a bell, 3 something 7. That doesn't ring a bell as a Pythagorean triple. So it looks like I'm just going to use Pythagorean theorem. 7 squared is equal to y squared plus 3 squared. So this is 49 is equal to y squared plus 9. Let's subtract 9, and now we're at 40 is equal to y squared. And let's take the square root. So now we've got square root of 40 is equal to y. Square root of 40's got some work to do because there's a perfect square hiding in there. Can't I make that the square root of 4 times the square root of 10? So this is ultimately 2 times the square root of 10. That's what y is equal to. Okay, so, and I do know that it's positive because I am going up. So y is the 2 square root of 10 distance. So sometimes we're not going to get it's not going to always be integers, right? It's not always going to be a Pythagorean triple like 3, 4, 5 or 8, 15, 17. Sometimes we got some radical work to do, but I always want you to simplify your radical. So that's the first thing, making sure that we have a full, complete picture. We drew an angle in quadrant 1. We labeled the sides that were given in the problem based on the ratio that was given, cosine, that's your ka, and then you just go find the missing side using Pythagorean theorem. Okay, so really now all we're looking for is what's the sine of beta and what's the tangent of beta. And I'll have answered my questions. Well, okay, well, sine of beta is the opposite divided by hypotenuse. Now that I've figured out what my opposite side is, I know that it's 2 divided by the square root of 10, or excuse me, 2 times the square root of 10, and I'm dividing by the hypotenuse of 7, and that's it. Tangent is going to be the opposite divided by the adjacent. Opposite side, again, is 2 times the square root of 10. This time, the adjacent side is 3. Nothing to do there. We are finished. The meat of the work was in figuring out what the picture of beta looks like, and there it is. Let's look at a similar type of problem. Given that the sine of theta is equal to 1/3 and this cosine of theta is less than 0, find all 5 others. That means find all the other 5 trig values. I know the sine value is 1/3. I want to know all 5 of the other ones. Again, unfortunately, I'm not able to use the unit circle. If I could, it would be kind of an easier problem because then I have all of the values. This is a 1/3. That is not one of our special unit circle values. So I know that we're going to be drawing a picture. The question is, what quadrant will we be using? They didn't specifically tell us which quadrant this time. Now, they did tell us that the sine is 1/3. That means that the sine is positive. And since we know that the sine is the y coordinate, right, that sine goes with the y-axis, we do know that we're going upward. So we must be either in quadrant 1 or quadrant 2. That's why they give us a second piece of information. They're telling us that cosine is less than 0. That's another way of saying that the cosine, of course, is negative. And if the cosine is negative, we cannot be in quadrant 1. The cosine is negative over here in quadrants 2 and 3 because the cosine goes with the x-axis, and if the x-axis is going in the negative direction, then we must be in one of these two quadrants. So we have to piece both of these pieces of information together. The sine is positive, so we're up. The cosine is negative, so we're left. So where are we in combination? Right in here in quadrant 2. So I'm originating from the origin and I'm just drawing an angle out there. Again, I always just make it a 45-degree angle. It's really just a picture. And I'm drawing my triangle down to the x-axis. Now I need to label my sides. Again, that's back to SOHCAHTOA. I'll do it down here. SOHCAHTOA. What did they give me this time? They gave me that the sine was 1 over 3. So the sine is opposite over hypotenuse. Opposite would be 1. Hypotenuse would be 3. And now I see that our missing side is right here, and I'll label it as an x since it's the x direction. This does not ring a bell as a Pythagorean triple, so I'm just going to do some Pythagorean theorem. 3 squared is equal to x squared plus 1 squared. That is 9 is equal to x squared plus 1. Let's subtract 1, and now we have 8 is equal to x squared. So that means that I'm going to take the square root. Square root of 8 is equal to x. And now we've got some work to do here, and it looks like there's another 4 that's hiding in there. Square root of 4 times square root of 2, so this becomes 2 square roots of 2. Just simplifying our radical. So this should be 2 square roots of 2, but I've got a problem with that. Because didn't we go to the left? So shouldn't this be negative 2 square roots of 2? That's why we always have to remember that when we're taking the square root of something, we have to remember plus or minus, plus or minus, plus or minus. And then we have to make sure that our picture makes sense. In this case, we are negative. So watch out for your signs, S-I-G-N's, that is. Okay, so we are looking for all 6 of the trig ratios. Well, 5 other ones. We already know that the sine is 1/3. We're looking for cosine, and we're looking for tangent. Let's just stop right there. Let's just do these 3, the main 3. Cosine, we're going back to ka. Now that we have a complete picture, of course. Cosine is adjacent over hypotenuse. Adjacent is this negative 2 square root of 2 divided by the hypotenuse, which is 3. Okay, that looks good. And the tangent, now we're going to the TOA. That's opposite over adjacent. Opposite is the 1. Adjacent is the negative 2 square root of 2. So the tangent is 1 divided by negative 2 square root of 2. I see 2 problems with this. First, negative sign should never be in the denominator, but that's not too bad. We can just float that negative sign on up. But we also have a square root in the denominator, and that's no good. So I do have to rationalize. I'll multiply by square root of 2 over square root of 2. So now what do we have here? The negative is going to be up top. Square root of 2 is up in the numerator. We've got a 2, and then multiplied by a 2 that escapes from the square root of 2 times square root of 2. So ultimately, it looks like I've got negative square root of 2 over 4. That's what the tangent is. So we've got our sine, we've got our cosine, and now we've got our tangent. There we go. Now we just need to find reciprocals. The reciprocal of the sine is the cosecant. And that's really not that difficult because the reciprocal of 1/3 is simply 3. Finished. We've got the secant that we need to find here. And we've got the cosine value, so now we just have to flip it upside down. But now we've got the same exact problem that we had with the tangent. So I do need to float the negative sign up, and I need to rationalize. So let's see if we can do that all together. The negative is going to come up here, of course. Negative. We've got 3 square root of 2 in the numerator. In the denominator, I've got a 2, and then I've got another 2. So it looks like we've got 4. So I've got the cosecant. Now I've got the secant. And lastly, I've got my tangent. Excuse me, my cotangent. The cotangent is the reciprocal of the tangent. But now let's think about this. This is the tangent value that we simplified. We could take the reciprocal of this, yes, but we'd have to rationalize again. This came from an unsimplified version of this. Why don't we just take this and take the reciprocal of that, because I'm pretty sure that that would be the answer. 1 divided by negative 2 square root of 2, that's no good for the tangent. But if we take the reciprocal of it, that's perfectly fine for the cotangent. I'm not going to put the over 1. Finished. Thanks for watching this tutorial, and we'll see you in class. We'll practice this some more. Well, thank you. Bye-bye.